This video is about forces and bosons within the Standard Model. What are we going to be learning about? That bosons are what we call force mediating particles. We're going to learn the names of the four fundamental forces, two of which you may know plenty about. We're going to learn the names of these bosons as well. So there are four fundamental forces. The electromagnetic force, so this is the force between charged particles. We might have called it the electrostatic force. So we know that if we've got a positive and a positive particle, they will repel, or a positive and a negative particle, they will attract. So that is the electrostatic force that combines with the magnetic part of it, because we can link them together in a theory, and we call that the electromagnetic force. So the magnetic part, we know magnetism, so that things that are magnetic can attract or repel each other. So we have the electromagnetic force. We then have the strong force, we have the weak force, and we have the gravitational force that we'll be more familiar with as well. So each force has what we call an exchange particle or a force mediating particle that goes with it. So the force that acts on these objects is due to the exchange of these force mediating particles. It's not the force itself, but it allows it to happen. So if we got two positive charges and they repel, there's this boson, this exchange particle that causes that to happen. So let's consider within the atom the electromagnetic force. So what does it do? Well, it holds the electrons in the atom. We know the electrons are negatively charged, that the nucleus is positively charged. Those two things attract each other. That's why the electrons stay part of the atom. The boson or exchange particle for the electromagnetic force is called the photon. And we'll have heard of that in terms of photons of light. Let's look at the strong force. Well, you might not have thought about it, but if you think about the nucleus of an atom, we know it's made up of protons and neutrons. Why don't the protons repel each other? Why does the nucleus stay together? And the answer to that is because of the strong force. And that strong force has to be stronger than the repulsion between the protons to keep it together. So the strong force holds the quarks together to form the hadrons, the protons, the neutrons. The boson, the exchange particle, is called the gluon. Think of it as gluing the quarks together, gluing the nucleus of the atom together. The strong force between quarks and the individual protons is strong enough to overcome the repulsion between the protons themselves. And if we add in more neutrons, that makes it even stronger. The strong force only acts over a very short range within the nucleus. Then we have the weak force. The weak force is to do with radioactive beta decay. We know that beta decay is a fast-moving electron, and we mentioned previously that it could also be a fast-moving anti-electron. And that electron comes from the nucleus where there aren't any electrons. There's only protons and neutrons. And it's the weak force that changes or is involved in the change of these protons and neutrons into electrons, the beta radiation. The bosons to do with that are the W and Z bosons. Despite being called the weak force, it's not actually the weakest of the four forces. the gravity is weaker than that. But it again acts over short ranges up to the points of where the electron orbitals are. Gravitational force is the weakest force. It acts between things that have mass, and its boson is called the graviton. We can't actually explain gravity in the Standard Model. So it's in there, but physicists can't explain it in the same way that they can explain the other forces. So it may be that we need a completely different model to explain things properly. So let's look at what we've talked about. We've got these bosons, these exchange particles or force mediating particles, and what do they have to do with things? And all you really need to know is the names of them and which force they go with, or given the force, what's the names of the bosons. You don't have to have a clue about explaining how they work. So we have photons for the electromagnetic force, the W and Z for the weak nuclear force, the gluons that glue the atoms together and make up the strong nuclear force, gravitons that we've never detected that we say help the gravitational force, and we've got another one at the bottom there that's not to do with forces but helps explain mass, and this is the Higgs boson, which you may have heard from the news, named after Professor Peter Higgs from Edinburgh, and it helps to explain mass. Again, not something that we need to really know about. Okay, so here's our summary of our Standard Model, a picture there, and we have our 6 quarks, up, down, charm, strange, top, bottom. We have our 6 leptons, electron, electron neutrino, muon, muon neutrino, tau, tau neutrino. So we've got those 12 fermions, and we've got those 3 different generations, all on normal matters made of up and down electrons and electron neutrinos. And then we have the other heavier particles that don't exist for very long. And then on the right there, we've got the gauge bosons that we were talking about, the gluon to do with the strong force, the photon to do with the electromagnetic force, and the W and Z to do with the weak force. And we have the Higgs to do with mass. So you need to know the names of the 4 fundamental forces. What are bosons? Their names, and just enough to say that they are the exchange particles to do with the force. That's the depth of the answer that you need for higher. What their names are, which force they go